Good morning. All right, so today we're doing lesson 5-4, which is interpreting remainders. All right, so we're continuing on with division, and we're going to actually do some division today that has some stuff left over. So it's not, your number's not going to go evenly into the other number. You're going to have some left over, so we're going to figure out how to deal with that. Okay, so a remainder is the part after you divide. The remainder is the part, well, I'll just write the part of what's left over. Okay, so what's left over. Okay, so that's the remainder. After you divide, it's what's left over. So let's go ahead and look on page 182. And we're going to look at the example there that's talking about Ned. Okay, so in this problem, Ned has a bunch of sports cards, okay, and he's filling up like a booklet. So each page gets filled up with sports cards. And it says he has 27 cards. Okay, so Ned has 27 cards. And he has this book, and you can put 6 cards on each page. Okay, so 6 cards on each page. So we're going to figure out how many pages, so how many full pages did he fill up? How many full pages did he fill up? And how many did he put, or how many were left over that he put on another page? So how many left over? Okay, so what we're going to do is we're going to count by multiples of 6, okay, until we get close to 27, but we can't go over because we don't have more than 27. Okay, so we're going to count by multiples of 6. So 6, and we'll just call those the pages. Okay, so 6, 12, 18, 24, okay, and then my next multiple would be 30, but I can't use that one because it went over 27 and I only have 27 cards, so I don't have 30, so I can't count that multiple. Okay, so I have to stop at 24, and then to find out how many are left over, I do 27 minus 24 is 3. So there was 3 cards left over. Okay, so how many full pages did he fill? He filled up 4 full pages. Okay, so he had 6 and then 12, 18, 24. All right, we're counting by multiples of 6 because 6 cards go on each page. All right, so he filled up 4 full pages, and he had 3 cards left over. Okay, so now the way that you would write that as an actual division problem, I'm gonna erase that. I would write it as either 27 divided by 6. Okay, you could write it that way. All right, but to actually do the problem without drawing pictures, you want to write the problem like this: 27 divided by, so this box means divided by, and the big number goes inside. 27 divided by, and 6 goes on the outside. Okay, and then you would write 6 goes into 27 4 whole times. All right, so 4 whole times. You'd put it over the 7, okay, because you're talking about the whole number. You're not just talking about the 2, so you wouldn't put it over the 2. Okay, you're talking about this whole number 27. 6 goes into 27 4 times. And then we're going to subtract the 24, so minus 24. And we get 3. That's what's left over. So the leftover part, you're going to write a little r next to the 4. Okay, I don't think it matters if it's a lowercase or capital, but an r for remainder, that's what's left over, 3. So the answer to this problem, 27 divided by 6, let me erase here, 27 divided by 6 equals 4, so 4 whole pages, remainder 3, with 3 left over, okay? They would go on the 5th page, all right? But you got 4 whole pages with 3 left over, okay? So that's what we're doing here, okay? We're taking a larger number, dividing it by a smaller number, okay? We're gonna write how many wholes. So this is how many wholes and how many left over that don't make this whole number. So there's 4 6s. Okay, there's 4 6s and 3 left over. All right, so I'm gonna erase this and we're gonna do another example without all this writing, okay? Okay, so let's take a look at, we can use our multiplication table too, and I'll show you that. Let's do 20 divided by 6. That's this top part right here. And I'll show you how they use this picture that they drew. Okay, that's on page 183. So 20 divided by 6. Okay, so this is the number I'm going to count by. Okay, I'm going to count by 6s until I get close to 20, but I can't go over because I don't have more than 20, so I can't go over 20. So I'm going to count by 6. 6, 12, 18, and then I have to stop there because if I go one more, it's 24 and it's too much. Okay, if you need help counting by 6s or whatever number, you can use the multiplication table. Okay, so if I count by 6s, well, I'm not going to count the 0 because there's nothing there. It's just 6 times 0, which is nothing. So I start with the 1. So that's 6, 12, 18, 24, and so on. I'm stopping at 18 because I only have 20 in the example. It's talking about apples. I only have 20 apples. Okay, and then in the book they're drawing a picture, so you could have 1, 2, 3, 4, 5, 6, and then what is it that they're saying? In a basket. So I'm actually going to draw a basket. Okay, so they're making baskets. They have 20 apples, and they want to put 6 apples in each basket. So how many whole baskets would they have? This basket has 6. This basket has 6, which makes 12. This basket has 6, which makes 18. And then I can't go anymore. If I would have a 4th basket, but I would have to figure out how many go in that basket because I'm at 18 and I only have 20 apples. So you'd find the difference between 20 and 18. So 20 minus 18 is 2. So 2 apples would go in this basket. This is what's left over. Okay, this is your remainder. Because I didn't have a whole nother 6 to go in that basket. So only 2 left over. So then when you do the division problem, it's how many times does 6 go into 20? 6 whole times. 3. Okay, so 3 whole times, okay, with 2 left over. So remainder 2, 3 remainder 2. So I want to show you though what that looks like just written as a division problem. Okay, so if I wrote 20 divided by 6 as a division problem, the way that you would do it mathematically, all right, like the algorithm that you use, not drawing pictures, you would say how many times does 6 go to 20 without going over? 3 times. Okay, that's 18. 6, 6, and 6 is 18. So you subtract the 18 from the 20, okay, to find out how many are left over. That's 2. There's 2 left over. That's this little basket here. So you write remainder 2. Okay? Now I think in the book, they're having you write it like this. They're giving you the division problem, and then there's a blank, and then it says with, and then a blank left over. Okay, so to fill it out in the book, we would write 20 divided by 6 equals 3 with 2 left over. Okay, so I'm going to erase that. And we'll try another one without a picture. I know I said that last time, but this time I mean it. Okay. Pictures are good though. They really kind of help you see what's going on. So let's see, 47 divided by 3. 47 divided by 3. Now, this would be a really good problem. We can't really use my multiplication chart because it only goes up to 12s. Okay, so I can count by 3s. All right, I can count by 3s, or I can write this as a division problem and do it that way. I can show you that way too. So let's start by counting by 3s, okay? Because I need to know how many times 3 goes into 47 and then how many are left over, okay? So I'm just going to count by 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 46, 47, 48. Okay, that's too many, so I'm not going to use that. 48 is over 47. Make sure I counted 36, 37, 38, 39, 41, 42, 43, 44, 45. Yeah. Okay, so then I count how many times that was. How many multiples of 3s did I count? So just count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. With blank left over. Okay, so if I stopped at 45, I'm going to do 47 minus 45, and I get 2. So 2 left over. Okay, so that's how you can do it by counting all your multiples. All right, I would have used my multiplication table, but it only goes, I'm counting by 3s, and my chart's 12 by 12. It only goes to 36. Okay, so it didn't go big enough. But let me show you another way. Okay, I'm gonna erase this. And we're gonna do it the way, this is called the algorithm that you would use. So 47 divided by 3. Okay, now I would start by looking at the first number and I say, is 3 smaller than 4? Yes, it is. So that means that 3 would actually go into the first number, 4. So I could say, how many times does 3 go into 4? Well, once, right? Because 3 times 1 equals 3. And if I did 4 minus 3, there's 1 left over. Okay, so 3 goes into 4 one time, and then there's 1 left over, okay? Now, since I have this 7 here still, I'm not finished dividing. So I'm going to actually bring that 7 down and add it onto the 1 down here at the bottom. And now I'm going to repeat this division. So I'm going to say 3 goes into 17. So how many times does 3 go into 17? And I can count that on my hands probably. So 3, 6, 9, 12, 15. That's 5 times. Because if I go one more, it'll go past 17. So that's 5 times. So 3 times 5 is 15. So that is what I'm going to subtract from 17 to find out how many are left over. There's 2 left over. And I'm done with the problem because I divided with this 7 here, okay? There's no more numbers. There's no more numbers over here. So I'm done with the problem. So it's 3 goes into 47. So first I did the 4 and then I did the 7. 15 times with 2 left over. Okay, so I get the same answer, and eventually we'll get here. And maybe you're there now. Like if you want to start trying to practice dividing like this, that's fine. But I think just in this lesson, you're just going to count your multiples. Okay, so the other way we counted all the multiples, we got 15 3s with 2 left over. And this, we used the algorithm and got 15 3s with 2 left over. So either way. Okay, so I'm going to erase that. Let's do another example. Okay, so let's look at 29 divided by 2. Okay, this problem would work the same way as the other one. You would either count by your multiples of 2, okay, or divide using the algorithm. So if I'm counting by my multiples of 2, that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and I'm not going to go any farther because that would be 30, and that's more than what I have. So I have to stop at 28. So I'm going to count how many multiples of 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 multiples of 2 with blank left over. Okay, so I stopped at 28, so I have to do 29 minus 28, that's 1. So 1 left over. So 14 with 1 left over. Now if I did it with the algorithm, it would look like this. 29 divided by 2. Okay, I would start with the first number. Does 2 go into 2? Yes, it does, 1 time. That's 1 multiple of 2, okay? So minus 2. So that would be 0. So I don't have any left over when I do 2 minus 2, okay? So then I still have to divide this 9, so I'm going to bring that down, the 9. So now it's just 2 goes into 9. I'll get rid of that 0. Okay, so 2 goes into 9. I'll count by 2s. 2, 4, 6, 8, and then 10 is too many. So 2, 4, 6, 8. So 4 times. 4 times, that's 8 minus 8. So 9 minus 8 is 1. I don't have any more numbers to divide, so I'm finished. So that's my remainder. Remainder 1. So I can get the same answer counting my multiples, okay, or using the algorithm. Now, counting your multiples is fine for now with these smaller numbers. But when you get into the hundreds and thousands, we're going to want to make sure we're doing this algorithm because counting by multiples will be way too time consuming, okay? So I'm going to erase this and I'll send you with your problems to do. So if you need help, you can go back and watch the video and look at the 2 different ways that I did the problems, or you can write these 2 different ways down in your math notes so that you have something to look back at when you're doing your problems in your book, okay? So we're gonna erase this. Okay, now let me see what problems you're supposed to do. And is okay, so pages 181 to 182. Oh, no. 183 to 184. So pages 183 and 184. And you are going to do, well, I already did number 3 and 4. Okay, so you're going to do 5, 6, well, 3, 4. You can copy down what I did on the videos. You can go back and watch it if you didn't write it down. 3, 4, 5, 6, 7, 8, 9, 10. 14 and 19. So 2 problems on the word problem part. So 14 and 19. 14, you're going to use the table with the problem. Samuel has 85 prize tickets. How many marbles can he get? So marbles are 7 tickets each, so you'll count how many 7s go into 85 and then how many left over. Okay, so how many marbles can he get? And then number 19 is this one down at the bottom. There are 39 children at a park. They want to make teams with 9 children on each team. 2 of the children go home. So 2 go home from 39. How many complete teams can they make? Okay, so that's how many times does 9 go into 37, because 2 of the kids went home. So there's not actually 39, there's 37. So how many times does 9 go into 37? And that's how many complete teams, but they are probably going to have some left over. So how would they solve that? How would they solve having any kids left over? Okay, so that's it. Okay, that is it for today, and I will see you next time. Bye.